So today we're talking about similar figures, and here I have two triangles that are similar figures. We have triangle ABC, and we have triangle XYZ. Right here we have a mathematical statement that says triangle ABC is similar to triangle XYZ. This little symbol right here in the middle stands for similar. So anytime you see one little squiggly line, that means is similar to. So since this statement already tells me that these two figures are similar, I know automatically that corresponding angles have to be congruent and corresponding sides have to be proportional. And if you remember from class, we have our little cap here, CAPS. We know that our figures have to be the same shape, and then corresponding angles, proportional sides is what we remember, how we remember that. So corresponding angles, proportional sides. Okay, so since I know that the corresponding angles are congruent, let's go back to our colors. I know that YZ is the bottom here, so it has to be, since they're facing the same direction, the bottom here is corresponding. So I know that Y corresponds to angle B, and I know that angle Z corresponds to angle C. And angle A and angle X correspond to each other. So if corresponding angles have to be congruent, I know that B and Y are both 90 degrees because it has the 90 degree the right angle symbol. But if Z is 40 degrees, I automatically know that C must be 40 degrees. So how do I figure out what angle A and angle X are? Well, I already know that the sum of a triangle's angles is 180. So I can take 90 degrees plus 40 degrees, and I get 130 degrees. And if they have to add up to 180, I can do 180 degrees minus 130 degrees, and I get 50 degrees. So I know that both angle X and angle A have to measure 50 degrees. So corresponding angles we've used to find the angle measurements. And now we're going to use the corresponding sides being proportional to find missing sides. So I know that AB is 6 and BC is 8. And we're going to say that YZ is 4 and XZ is 5. So we're going to look for the missing side length of AC. So if I do green over purple, I'm going to start with this. I don't know what this one is, so that's my variable. And I have 8 as my purple, and then I'm going to move to the smaller figure, and I have 5 is the green and 4 is the purple. Well, if I look here, I can see my rate of change. I know from 8 to 4 I divide by 2, so since I have to move this way, 4 times 2 is 8, so 5 times 2 is 10, which means that line segment XZ measures 10 units. So this equals 10 units. Now we could also find out what XY is by setting up a proportion. So let's do the same thing. This time we're going to use, I'm looking for the blue. So we need to make sure we have blue. So we can either do green over blue or purple over blue. So I'm going to do purple over blue. I'm going to have you set this one up by yourself. Remember, this one should be from the larger triangle, and this one should be from the smaller triangle. Okay, set that up, and I would like you to use the strategies that you know for solving proportions to figure out what that missing side length is. So in your whisk, I'm going to ask you what the measurement of XY should be. All right, good luck.